Hello and welcome to the Old Fliers. We have presented videos on materials used in aircraft construction, namely aluminium, of course, titanium, magnesium, cloth, wood, composite materials and carbon fibre. Many other substances are used in the construction of aircraft: copper, plastics, steel, ceramics, glass, lithium, lead, rubber and paint. One material that might come as a surprise is the metal sodium. It is to be found in the exhaust valves in piston engines, there to improve heat transfer. Exhaust valves have hollow stems which are filled with sodium during manufacture. A licensed aircraft maintenance engineer said to me that sodium was a fun metal. He said that as a first-year apprentice in 1960 in the MMA engine shop, he cut the heads off unserviceable valves and dropped them into about a gallon tin full of water, under supervision of course. Lots of fizzing and gassing, then a bang as the gases ignited. He said they ground back the valve stems to use as wad punches. Sodium is a very reactive metal. Here is Professor Sir Martin Polyakov explaining.
Sodium is again a light metal, rather like lithium, and it has a melting point about 96 degrees.
Reacts very, very quickly with air and also with water.
And many of you will know that if you drop sodium into water, it reacts almost explosively.
So let's see what happens. See what this reaction's like. So it's reacting really quite quickly and really violently with the water. And you can see it's fizzing around as it's generating lots and lots of hydrogen gas. And you see now the heat from the reaction is burning away all of that hydrogen which is generating, and you can see the orange sodium flame.
Engineers building heliostats chose sodium to transfer solar heat to molten salt reservoirs. Heliostats are the high towers where concentrated sunlight, reflected from focused multiple mirrors, shines on small areas, heating there to over 500 C. The molten sodium conveys the heat away. This stored heat is then available to create steam to power turbines to generate electricity. Here is CSIRO's Chris Stein explaining how this works.
A little bit about how the technology works first of all. This is the Bright Source project over in California. It's one of 3 135 megawatt projects. This was a fantastic project that spans around about 2.5 kilometres in diameter. All of those heliostats, all of those mirrors on the ground are tracking the sun up onto the boiler, generating steam for a power block for a steam turbine, which is just very conventional technology. Likewise, looking at one of the main new recent developments in solar thermal has been the use of molten salt to enable storage. So we have a cold tank sitting at about 240 degrees. The salt looks a lot like water at that temperature, heated up to nearly 565 degrees Celsius. And that hot salt then flows back down to the hot tank, and that storage sits there as hot salt, ready to be available for steam generation into a steam turbine whenever you want it. Vast solar. But they've pushed the boundaries a bit, and instead of using molten salt, they're using sodium as a heat transfer fluid up in each of these receivers.
Sodium is used as a coolant in some types of nuclear reactors, such as fast breeder reactors as well. Its excellent heat transfer properties make it suitable for this purpose. Proper handling and storage procedures are necessary to prevent accidents. Not to forget, without sodium as sodium chloride or table salt, our bodies could not function. Such a benign compound derived from such a reactive metal. Thank you for watching. Liking and subscribing, much appreciated. If you have an aviation related topic you would like me to cover, please leave a comment.